Folks, today we're going to work more with the unit circle that you started to learn about last time. Okay, the goal for today is to get from just knowing the 4 original points on the unit circle to being able to find any of these marked points that you see on the circles below here. In order to do that, we have to bring back some geometry. What I'm going to have you do is try this first section. Okay, up until the bottom of the circles, you don't have to answer the questions below. And then when you're done with that, you can come back to the video, make sure you understand all those pieces to be able to answer those questions below. Okay, so pause the video now and try those. Okay. So here, these are similar triangles, so hopefully you recognize the scale factor here was multiplying by 1 over the square root of 2. I know that seems weird, it's really dividing by the square root of 2. Okay, but we a lot of times talk about scale factors as times. So we've got 1 over the square root of 2 for these ones. But you do have to rationalize these. We're not allowed to have a square root in the denominator of a fraction. So this would be the square root of 2 over the square root of 4, which is 2. Okay, same thing goes for this one. It's just square root of 2 over 2. And then over here, our scale factor was a half. We're dividing by 2. So this would become 1 over 2. And square root of 3 over 2. And how this is going to help us is because these two triangles that we had this radius of 1 on is going to relate to the unit circle because we can place this triangle in here knowing that the radius is 1 and a radius can be drawn any direction. All those lengths of those little segments going throughout are 1. And so we're going to focus on this triangle versus the one that you learned about in geometry because these are similar triangles and will have the same proportions of sides. Okay, so with that in mind, we know that this 30 is just dragging down this 1/2 and this square root of 3 over 2. So then the x value of this ordered pair, because we're just focused on this point, is the square root of 3 over 2. And the y value of that point is the 1/2. Okay, similarly, you can find the other ones. Okay, so check those ones, just pulling down that triangle. And we're going to use those ideas combined with what we talked about last time to answer the questions below. Okay, so as a reminder, if you need to, write down your ordered pair. Remember, the x value goes with cosine of the angle. The y value goes with sine of the angle. And tangent is the ratio sine over cosine. Okay, and when we're talking about ordered pairs, it's more natural for us to think about this as x, y, and then y over x. Okay, so using those 3 points, what I want you to do is pause the video again and just find those values based on the pictures, not with your calculator. Okay, try that now. Okay. So here we just wanted 1/2 square root of 3 over 2. On this one we had square root of 2 over 2 for both sine and cosine. And for this 60 triangle, the sine was the larger side. Square root of 3 over 2, and then 1/2, just stealing the x and y values. Now I intentionally left tangent for last because you may have struggled simplifying it because both of our y values and our x value, our sine and our cosine, are fractions in this case. So we just have to be careful. We want 1/2 over the square root of 3 over 2. And so I put those parentheses on there. Unfortunately, you don't want to use your calculator to help you with this because that square root of 3 is going to turn into this really ugly decimal, and we want to leave it exact. So we have to practice just multiplying by our reciprocal, which is 2 over the square root of 3. That part's gone. And then our 2's cancel out. We have 1 over the square root of 3. From there, just like we did with the square root of 2 over 2, we have to fix this so it doesn't have that square root symbol in the bottom. Multiplying by square root of 3 over square root of 3 to get rid of that square root of 3 on the bottom. We get the square root of 3 over the square root of 9, which is 3. Okay, no problems there. Same thing goes with the next two. Square root of 2 over 2 over square root of 2 over 2. And that's a big messy fraction, but it's 1. Okay, because anything over itself is 1. Last one, we've got square root of 3 over 2 divided by 1/2. It's the same thing as multiplying by 2. Again, that's gone, and those 2's cancel, so we just have the square root of 3. Okay. I do want to take a minute to remind you that this relates directly to the triangles that you had in regular geometry. Okay, so I'm going to focus on this 30-degree triangle right here, just to remind you of those things. This is cosine of 30. This is sine of 30. And tangent, we decided, was our 1 over square root of 3, and unrationalized, of course. But I want to show you how this works on a regular triangle. If we go back to SOHCAHTOA, okay, sine is the ratio opposite over hypotenuse. Well, opposite over hypotenuse is 1 over 2, which is 1/2. Cosine is adjacent over hypotenuse. Adjacent is the square root of 3 over the hypotenuse is 2. Okay, and then our tangent ratio, opposite over adjacent, is 1 over square root of 3, and that's why I mentioned the non-rationalized version. Okay, so there's nothing actually wrong with using our regular triangles because they are similar. They will reduce to the same fraction. The benefit of doing it this way is we don't have to really do the divided by the hypotenuse because dividing by 1 is the same value. So it allows us to see that answer a little bit more quickly. So long as we get the habit of those new ratios, okay? And that's what we're going to practice, okay? So we're going to do some problems here. It's going to be very similar to how we started last time. Okay, step 1 is figure out where that would land you. We're not just on one of the 4 points anymore. We can be anywhere around the circle as long as it lands on one of our special angles that we've been working with, or their multiples. Okay, so to start this, what I want you to do at the top of the page is remind ourselves of some of the radian values that may pop up. Okay, if you remember, we had some multiples of pi over 3, we had some multiples of pi over 4, and we had multiples of pi over 6. And they all dealt with our special triangles because 180 over 3 is 60 degrees, 180 over 4 is 45 degrees, and 180 divided by 6 is 30 degrees. So if we know we see a fraction that has 4, 3, or 6 in it, then we know that we're dealing with one of our special triangles that we were just talking about. So this one is going to be a special triangle of 60, but we want to go clockwise that. I do want you to think about this in radians, so I'm going to have you practice with this being pi, and because this fraction is over 3, we can call this 3/3 pi. That'll help us locate some of these without converting. In this case, it was just 60, but a lot of times it's going to be like 5/3 pi or something like that. We don't have to convert to figure out where it lands. We just have to think about our fractions here. So this is negative 1/3. So I'd go clockwise 1/3 of the way. There's 2/3, there's 3/3. Okay, and just put a point. Just like we had our original 4 points, this is a point on the circle. We just won't draw the circle itself. Okay, but I do want to point you back here to kind of see the idea is we have this point, and our job is going to be really to make right triangles out of these things, because my right triangles can get me all of these points around, because there's a 30 degrees, there's a 45, there's a 60, and then on the other side we've got this reflection. That's a 60-degree angle triangle here, even though it's not 60 to get you there. Okay, so for this one, draw a point. And to make your triangle, you're going to connect your point to the origin. That's going to represent the radius of the unit circle. And then our angle is always measured from the origin. Okay, so what we're going to do is always connect it to the x-axis. Okay, so origin and x-axis to make your triangle. And we already decided this 3 meant we're going to have a 60 degree in the corner here. But now we're just practicing with our side ratios that we just talked about. If this is the radius of the unit circle, then the length is 1. Okay, our other 2 sides on a 30, 60, 90 with a hypotenuse of 1 are 1/2 and the square root of 3 over 2. From what you know about triangles, the largest side is across from the largest angle, and the smallest side is across from the smallest angle. So here, the 60 degrees is the larger angle, so it'll be across from the larger fraction, the square root of 3 over 2. And the other side, the one left over, will be our remaining 1/2. The only other thing we have to do before answering the question is attach signs, because all the problems we were just doing were in quadrant 1, And everything's positive in quadrant 1 because to graph a point, we go to the right and we go up. So we're going to talk about just this ordered pair. If I was graphing it from 0, I would go to the right, so that should be a positive 1/2. And then I need to go down, so that's a negative square root of 3 over 2. So if I think about my ordered pair, this would be a positive 1/2 and a negative square root of 3 over 2. And from there, the sign value of that goes with y, and it's negative square root of 3 over 2. And the more we practice with this, the faster you'll get at it. Okay? So this one, again, it's in radians, so I'm going to put a pi here. And then this fraction, since it's over 4, will be 4 over 4. We're going the regular counterclockwise direction, so this is 3/4, so I'm going almost to that 4/4, just put a point. Imagine rotating on your circle here. And then we make the radius of that circle by connecting it to 0, and then straight to the x-axis. In this case, we're going down. Now, if this is 4 here, then that has to be a 45-degree angle in the corner. Okay? Because, remember, here, if this is 4/4 and this is 3/4, it's 1/4 away, or 45 degrees away from that 180. Okay? And we're going to mark our sides. The hypotenuse is 1. Our other two sides, this is a 45-45 triangle. Our other two sides are the same length, and that was our square root of 2 over 2. Same thing as on the last one. We're going to do sines next. So we're trying to get to this point. We have to go to the left, so that's negative, and then we have to go up, that's positive. So this ordered pair would be negative square root of 2 over 2, and then positive square root of 2 over 2. But I only care about the cosine, so I only care about the x value. So negative square root of 2 over 2. Okay? For me, you don't have to write this ordered pair if you don't want. If you get comfortable, we know the sine is the y value. Okay? We just know it's that side of the triangle. Same thing here, cosine is the x value, so it'd be this side of the triangle for the answer. Okay, we'll do 2 more together, and then I'll let you practice some on your own. Cosine of 120 degrees. This is going to be faster to find where it's located, but we'll have to work a little bit to talk about the angle in the corner. So 120 degrees is not quite the 180, so it's going to be over here. But we are going to use that 180 degrees. Instead of pi, since we're in degrees, we're using 180. We're still connecting it to the origin and to the x-axis to make our right triangle. But we have to come up with this angle on our own. There's no radian value to help us. Okay, so we know 120 is measured from our starting point over at the right. And basically, we're finding what this little angle is. So 120 of it's here. I haven't made it to 180. I am 60 short. So basically, you're going to take your 180 and subtract off that angle we have to get your result. If your number is larger than 180, okay, like over here, you would take that number minus 180 to find the difference going backwards. And if it's over here on this side, then you're going to use 360 and do the same thing, subtract off. Okay. So we've got our 60-degree triangle. Now we're ready for the sides. Okay, again, the hypotenuse is 1 here on the unit circle. And then we've got a 30, 60, 90 triangle. So my sides for that are 1/2 square root of 3 over 2 and 1. And across from the 60 is the larger side. So it's got to be the square root of 3 over 2, leaving the 1/2 on the bottom. If I think about signs, to get to that point, I have to go left, negative, then I have to go up, positive. Okay, so here, if I look at cosine, I just care about the x value. So that'll be this value across the bottom, or negative 1/2. Okay. Tangent, 4/3 pi. Okay, so I'm back to using radians. This is 3/3, using my fraction on the bottom. So going counterclockwise, here's 3/3. 4/3 would be past it. Draw a point. Make your triangle. Okay, angle in the corner comes from this. If we see it divided by 3, a pi divided by 3 is 180 divided by 3, which is 60 degrees. And then we label our sides. Okay, just like the last triangle, across from it we've got square root of 3 over 2, Next to it, we've got the 1/2 and hypotenuse 1. Okay, to get to this point from the origin, we have to go left and down. And we're looking for the tangent. So this is the y value over the x value. We're going to have to do some simplifying. Okay, so our y value is this fraction. It's a negative square root of 3 over 2. And our x value is this one on the top. And then we have to multiply by the reciprocal. A reciprocal flips the fraction, but it does not change the sign, so be careful of that. We've got a negative times a negative is positive, and then those two cancel out, leaving you the square root of 3 over 1, which is just the square root of 3. Okay, another option here, if you struggle with fractions, like I said, you can, in theory, do these all with a regular triangle. It's not on the unit circle, but we can talk about a scaled out circle and go back to our 1, 2, square root of 3 and find our tangent ratio, which is O over A. Okay, opposite side is our square root of 3. Adjacent side is our 1, and then with signs, those cancel, and we still get the square root of 3. Okay. Again, the benefit of doing it with the 1 is because we see the x and y for our answer. We don't have to think about what fraction applies. Okay, but that is an option for you. Okay. So now what I'd like you to do is pause the video and try number 5, 6, 7, and 8. We'll come back together for the last 3. Okay, let's check. The first 2 weren't so bad. I do want to mention same thing with these degrees, 180 to 210. I went 30 past it. That's how you find that angle. And then again, check for signs always. But I do want to talk a little bit more about 7 and 8. Okay, some strategies for figuring out where those are when we see larger fractions with radians or we see larger numbers in degrees. So here, one strategy for radians is change it to a mixed number. So this is 2, 5, 6 pi. So 2 pi is 1 lap around, and then 5, 6 more just goes this extra. Okay, and then we can fill in our triangle from there, knowing that the 6 on the bottom puts a 30-degree angle in the corner. Okay. On this one option is to keep subtracting off 360 until you get what's left, and that would be this 315 or negative 315. Okay, another option is dividing by 360, which changes it into how many laps around the circle you go. Okay, so this would say negative 2.875 laps. So I'm going clockwise, 1 full lap, 2 full laps, and then almost 3 laps puts me in quadrant 1. Okay, if you forgot the clockwise, you would have ended up here and gotten the same answer. Okay, but I am going to grade your picture as well, so it's important to me that you are getting the right answer not by luck, but because you know where this angle lands you on the unit circle. And now we're going to go the other direction. So this first one deals with what we talked about last time, but in general, here's our strategy. Cosine goes with the x-coordinate of the ordered pair on a circle. So we are thinking of any point along this circle, and now we've talked about lots of them. We have the first 4, but we also have the 3 in each quadrant based on the special triangles that we talked about today. So for us, we want to talk about where x values are 0 on a graph. Okay, so that means we're going 0 left and right, so I have to be at the top or at the bottom of my circle. Okay, it's the whole x equals 0 is this whole y-axis, but I only care about points that are on the unit circle. And we talked about this last time. Okay, I don't want to answer this as the ordered pairs, but I want the angles that would make this a true statement. And there are 2 of them. The angles should be in radians based on this part, and that is pi over 2. If you need to start at 90 and convert, that's fine. This down here is 270, but that's 3 pi over 2. And those are individual values. It's not like what we did last time where there was a whole interval. Okay, so it's not from pi over 2 to 3 pi over 2. It's just those 2 numbers. So we're using set notation. The same thing is going to apply for 10 and 11. We'll have specific angles that work, not an infinite amount of answers that work because of the equal sign rather than the like less than or greater than that we saw last time. Okay, so process stays the same as this one though. We're thinking about y and thinking about where on a graph y could be a negative 1/2. Now hopefully you recognize that because this value is not 0 or 1, it's not at one of your 4 points, which puts us at what we talked about today, one of the 3 points in each quadrant that would apply to a triangle. Okay, so fraction is going to mean triangle for us. So we want to know where could we place a point so that we have a negative y value. Okay, and y is up and down on the graph. Negative would be down here, then in quadrant 3, and then down here in quadrant 4. And it doesn't really matter where you put them as long as they're around the same height, because that's the goal. We want this y value of the coordinate to be negative 1/2. And this y value of the coordinate to be the same negative 1/2. So visually, those numbers should check whether you're in the right place. And then you connect them to the origin, just like before. So there are 2 angles that get me to these 2 points, just like there were 2 angles that got me to those 2 points. In order to find that, we have to use what we did today and recognize what special triangle this is based on seeing the fraction 1/2. So if you go back to your 2 special triangles, we've got a 45-45 or a 30-60-90. And a 45-45 had the sides of square root of 2 over 2, square root of 2 over 2, and 1. And a 30-60-90 had square root of 3 over 2, 1/2, and 1. So because a half is showing up, this has to be a 30-60-90. And out of the 30 and 60, the angle that's across from that smaller side is the 30. Okay? All right, I know that's a lot at once, but it will get better when we practice these more and more. Okay, the goal is the angle. And all angles are measured from 0 going around this way, unless we're told otherwise. Okay, in this case, they want radians, so I'm going to have you start in radians. It's going to save us some time in the long run. So if we see a 30 degrees, remember that means the fraction is over 6, because 180 over 6 is 30. So this would be 6/6 if we stop here. But we got to keep going 1 more 6, because this is a 6 pi. So that gives me an angle of 7/6 pi. And then we're going to do the same thing. We're going to continue going until we get this angle. And this one is closer to this side. Okay, so this side is 2 pi. And we're doing the same thing. We're putting it as a fraction over 6. So in order to get 2, I have to take 12 divided by 6. And it's not all the way to 12/6. It's 1 backwards. So this one would be 11 pi over 6. It will always be 1 before or 1 after those horizontal values, because we draw our triangle with the horizontal. And this 30, 60, or 45 is always 1 something pi. So 1/6 pi in this case, so it's 1 section away. Okay, so I'm going to have you try to draw where this one would be located. Okay, so pause the video and try to place your triangles for this, and then we'll talk about the angles together. Okay, so this one, the y is a positive fraction, which would mean we're on the top half of the graph. Again, because it's a fraction, we have this on a triangle rather than one of our 4 points. We know sine and cosine have to be 0 or -1 when we're talking about the 4 points on the unit circle. But the y value is this fraction. Hypotenuse is 1, other side is 1/2. Okay, but the goal is not the sides, the goal is the angle. So if you can recognize what this angle is, you don't need to label the other sides. Okay, so here we're in a 30-60-90 triangle again, because that square root of 3 over 2 shows up. And across from the bigger side is the 60-degree angle. Okay, just like last time, we want to be in radians. If it's 60 degrees, we'll call this 3 over 3. Okay, and because we're on this top half, I don't really need to do these bottom values at this point. Okay, so our first angle is just 60 itself, which is our pi over 3. And then our second angle doesn't make it to 3/3, it's 1 backwards, so 2 pi over 3. Okay, but these instructions were slightly different. It also says go from -2 pi to 2 pi, not just 0 to 2 pi. This just says go clockwise too. So now what we're going to do is start at the same 0, but go the other direction around. And I know if I'm going clockwise, I have to have a negative on my answer. So here is -3/3. 1 past that would be -4/3 pi. Okay, same thing going around for the last one, all the way around. I don't quite make it to 2 pi, and I know that's 6 over 3 pi. So 1 backwards from that would be negative 5/3 pi. Biggest thing is to remember the negatives for the clockwise ones. Okay. You have a few of those on your homework. Please come see me if there's something about today's lesson that you're not understanding. Okay, I'm glad to help.